If you've tried doing some of the problems in section 5.2, you might notice there's a lot of work that you have to do with exponents. And for some of you, it may have been a while since you've had to do this kind of work. So let's do a little basic review if you're a little rusty with that. Let's do a group of problems dealing with exponents. If I start with 2 squared, well, what does 2 squared mean? The 2 as an exponent means there are 2 factors of this base, which means you have 2 times 2, which is equal to 4. If we make our base, well, let's keep our base 2, but make the exponent a 3, it means I have 3 factors of 2, and we get 8. So now, basic rules. If I have 2 factors of 2, and I multiply it times 3 factors of 2, well, what I have altogether is 2 factors of 2 here, plus 3 factors of 2 here, so I have a total of 5 factors of 2, which is where the rule that says when you're multiplying 2 things that have the same base together, what you're doing is you're adding the exponents, because you're counting how many factors there are. And this applies also when we're working with variables. So if I change the 2 into an x, well, x squared times x to the third, here I have 2 factors of x, here I have 3 factors of x, altogether I have 5 factors of x. And this applies no matter what our base is. If we make a base that looks more complicated, like ab plus 1, and I raise that to the second power, and I multiply it by ab plus 1 to the fourth power, well, here our base is going to be the same. Since the base is the same, we have the same base over here. We have 2 factors of that base here, 4 factors of the base here, for a grand total of 6 factors of the base. Let's look at one special case that's important to remember. Suppose I have x to the 6th times x. Well, wait a minute. What's the exponent on this x? The implied exponent is that you have 1 factor of x. So what you're doing is adding the 6 and the 1 to get x to the 7th. We have 7 factors of x. Now let's just go one step further and make that exponent a variable. X to the k times x to the b. Well, that's going to be x to the k plus a. Here I have k factors of x. Here I have a factors of x. Altogether I have k plus a factors of x. Something that happens often with these problems is you have x to the k times x, which is going to be simply x to the k plus 1. And if I have, let's say, x to the k plus 1 times another x, it's going to give me x to the k plus 2. Well, if you use these basic rules, no matter how complicated the expression is, you should be able to perform the operations correctly.